Morning everyone, and welcome to our second live session on our West Suffolk College STEMtastic collaboration events. And this morning we have got lovely Lorna with us. And Lorna is an engineer, and she's going to talk to us today a little bit about offshore energy and renewable energy. So Lorna herself has always had a real big passion for building things and solving problems like many engineers do. She was helping her dad during maintenance from a very young age, but she then went on to study product design engineering at the University of Glasgow and the Glasgow School of Art. Within this, she's really passionate about engaging young people within the STEM industry at an earlier stage, and she's also been a STEM ambassador since 2010. And she has spent and dedicated a significant amount of her time to STEM engagement programs, very similar to today, to make sure that others do not miss out on any opportunities offered by engineering. And she is here today to promote engineering, which is excellent. So Laura, over to you.
Thanks, Amy. I'll just share my screen. I've got a brief introduction, though you've covered quite a lot of it already. So yeah, I'll just talk a little bit about what got me interested in engineering, and then a little bit about what I do now to hopefully try and get you interested and get some questions going. So as Amy said, I was very into building things and creating things when I was younger. So Lego, Connect, Meccano, loved the DIY with my dad at the weekends. Flat pack IKEA furniture is a dream, and also baking and painting and drawing and all the creative things. So actually it was my love of art and design combined with my interest in science and maths that led me to engineering. And it was an open day that I technically shouldn't have been at because I wasn't a final year student, that my art and design teacher convinced me to go to the Glasgow School of Art open day in my 5th year of high school. And I discovered product design engineering for the first time. And when speaking to my physics teacher when I got back to school, he was really encouraging and me to go into engineering and registered me for the Royal Academy of Engineering Head Start programme, which was run by the Engineering Development Trust, which was a great course and just solidified my desire to go into that course. So as Amy said, it was a combined degree between the University of Glasgow, where I did all of my mechanical engineering and electrical engineering courses, but then we had design projects at the Glasgow School of Art. And now I work in the offshore renewable energy industry. And this is just a little bit of what my day-to-day job used to look like before the pandemic. But we have a offshore demonstration turbine in Fife in the east coast of Scotland, so just across the river from Edinburgh. And we use it as a research and demonstration facility for testing new technologies to try and help improve the offshore renewable energy industry in any way we can. So lots of new technologies for helping with operations and maintenance, so we can increase the efficiency of how the turbines actually operate and generate electricity, but also lots of ways of we can use technology to help improve technicians' working experiences offshore, so safer access, fewer trips offshore with more remote monitoring, and as you can imagine, probably lots of robotics so that we can do a lot of remote operations without actually having to send people offshore as often. So just a quick overview, the offshore wind industry is obviously growing. It's a huge industry and it's developing even faster. So on the top left picture there, you can see how much wind turbines have grown in size since 2002, when they were about the size of Big Ben, and they're now as tall as the highest buildings in London, up at the Canary Wharf there. So up to 250 metres tall, from just under 100, 18, 20 years ago. The bottom left is our offshore wind turbine in Fife, and the middle picture there is how we currently do blade inspections. So if we suspect that there's anything wrong, or we want to check that the health of the wind turbine blades themselves are fully the way they should be, we have to send ropes access technicians there to abseil down from the top to do a full inspection of the blades and make sure there's no damage and that everything's working the way it should. But one of the projects we're working on, this picture in the middle here, is a little robot called Bladebug, which will walk along the blades and do the inspections while the technicians are safe in the top of the turbine without actually having to go out into the wind and do that. Bottom left here, a picture of the Siemens blade, how they actually manufacture the blades out of the composite materials. They layer the materials together to make them light structures so that they can spin fast and capture lots of energy. They're huge structures, and it's just to give you an idea of the scale with the people next to them. And then obviously the latest development in offshore wind, looking at floating wind. So we've got 4 main types of floating substructures so that we don't need to invest in so much of a structure and actually have them bottom fixed like they are at the moment. So the better for deeper waters and potentially advantages for maintenance, large scale maintenance. But we also work with tidal power as well. So there's lots of different tidal devices. So the 2 main types are floating devices. So that's what it looks like on the water, but that's what it looks like out of the water, where you've got the turbines actually hang down and they spin as the tide blows past. And then we've got the bottom fixed ones as well, where they actually fix the bottom of the seabed and the turbines turn, much like you would imagine in wind turbines as well. And then there's lots of different types of wave devices. So these are not quite as advanced in their development, but there's a lot of research going on, and it's a very interesting industry to be in to develop these devices. You can see how they all move as the waves go past on the surface of the ocean. So that's just a very brief introduction to try and get some thought and ideas going around. I will try and stop sharing now and answer your questions. Best way just to read them out, Amy, and I can just read them and answer them as I go. Okay, so how has lockdown affected your role? It has affected the amount I have been travelling and visiting clients and project partners and actually going to site to do these demonstrations. But I was mainly office based before, so I am now based in my home office, so not getting out as much. We also usually attend quite a lot of conferences to meet people and try and develop those new ideas and those new projects. So all of that's been done virtually now, and we have had a few delays on some of the project demonstrations we would normally be doing on the turbine. But we're trying to schedule those in as safely as possible. So the demonstrations that we have been doing that normally I would maybe attend site to ensure that everything was running smoothly, I'm now just trying to coordinate all of that remotely and be on hand if there's any questions that come up while our clients are on site with our turbines team, and just trying to coordinate remotely rather than actually being there. So it's not affected it too much. Just not getting out as much as I would quite like to. Cost of a nuclear power station.
Mike.
Oh.
He's up
So,
there because he hasn't been attending Sally's lesson on Thursday.
sorry?
That's what I said.
Oh, I don't think she's talking to me.
Yeah, no, carry on. Sorry, I'm just muted.
It's okay. It's because I just clicked to answer the question and I thought I'd done something wrong there. So the cost of a nuclear power station, even decommissioning, would be equivalent to thousands of wind turbines. Why does the government not see this as a better and safer source of energy? That is a very good question. I think with the latest announcement that the Hinkley C power station has been delayed, there's a huge advance in offshore wind. The government budget last week announcing the money for the development of ports, which will be a big step forward for wind power as well as other offshore renewables. It's politics is a complicated issue that can interfere with a lot of industries, unfortunately. But you know, the wind industry is dedicated to this development. In 2019, they announced the wind sector deal, which was an agreement between major industry players, ourselves as supporting organisations, supply chain and government, to achieve a rapid development of the sector. So that includes, you know, a huge growth. So we currently have just over 10 gigawatts of wind turbines turbines installed today, and they want to reach 40 gigawatts by 2030. So we need to quadruple our current wind capacity over the next 10 years, and it's taken, nearly 30 years to get to that 10 gigawatts. But as you see, the growth of the turbines themselves are accelerating the growth in the industry. And the next hope is obviously that floating wind will be able to develop that a lot faster, because there will be less offshore working in windy, wavy areas that we want to put turbines in, so that health and safety aspects will be improved. The floating structures will generally be slightly smaller than the bottom fixed structures, so they can maybe be produced at a faster rate, potentially, if the port facilities are developed as, I say, part of the budget and things. So there's a lot of development. I'm not sure what's happening in the nuclear industry at the moment, and I hope that we can move forward to more clean energy going forward in the future. So how much per megawatt hour does a wind turbine typically cost, including installation offshore, for say a 12 megawatt to 15 megawatt turbine? That's a very good question. I haven't seen the latest figures, I'm sorry to say, but we are now down to less than £50 per megawatt hour, I believe. And the latest leasing rounds, they will be announced shortly, and we hope that figure will drop even further. So the megawatt hours, I think that includes the capex, so the capital cost of the installation as well as the operational costs. I'm not up on the financial details specifically. I have colleagues that specialise in that area with the analysis and insights team, so I would revert to them, but the cost is coming down all the time, and as I say, with the scale of the turbines increasing, the cost is coming down rapidly as well. How does the efficiency of wind power compare to tidal power? So they're difficult to directly compare, because obviously the scale is a significant factor. As the previous question alluded to, we're now looking at 15 to up to 20 megawatt turbines in the future, and we still only have largest scales 1.5 megawatt tidal turbines. The wind turbines can obviously be bigger because they're in the sky, whereas the tidal turbines are sometimes restricted by the depth of the water they're in, as well. Wind can blow very strongly and quickly, so you can generate more power, whereas tidal stream, you're looking at 1 to 5 meters per second, as opposed to wind, which can be up to 20 meters per second. So there's a lot of differences that are hard to compare, and also wind power has had more than 30 years of development than tidal turbines, really. So there's a knowledge gap there, there's an experience gap, but the technology is developing. It's very interesting to see how it's coming along, and it's just a shame that it's not had as much investment as the early wind turbines to help develop it faster. But there are companies that are doing incredible work, particularly with their demonstrations in Orkney and Shetland, and others developing down south, and can only hope that Swansea Bay is successful as well with the tidal lagoon, which again is a different type of technology altogether, but we know that tidal dams and lagoons, they work very well in other parts of the world, so it's very positive. Is wind power really is that a realistic energy source for the future? Yes, the biggest problem we have is that there is no or very little forms of energy storage within our network. The kind of internationally recognised best form of energy storage comes from reverse pump hydropower, where you have a hydropower station with a reservoir at the top of a hill or mountain, and then you've got the reservoir at the bottom, and the turbines sit in the middle. And when you want to generate power, you release water from the high reservoir, and it flows through the turbines into the low reservoir. You get reverse pump stations that take excess power from our grid and use that to pump the water from the low reservoir back into the high reservoir so that it's there for peak demand where we want more power. The problem we have currently with a lot of wind power is that we can't store the energy we generate. So on windy days, sunny days where people are maybe outside, they're not using as much electricity, we can't store that for cold, wet days where everybody's inside and wanting to use lots of electricity, watching the telly and heating and everything. So the biggest challenge we have is how do we store that energy from, say, those summer months for those winter months? And that is why one of the major developments that a lot of people are looking into at the moment is for hydrogen, because green hydrogen is produced by electrolyzing water, so using green electricity to electrolyze water to make hydrogen. And hydrogen can be stored, it can be used for heating, it can be used as biofuel, it can be used as hydrogen fuel cells to turn back into electricity. So there's a lot of arguments saying that hydrogen fuel cells aren't very efficient, but even if it's 20% efficient for generating back into electricity, it's better than the zero we currently have on our network. So there's a lot that can be done. Hydrogen is obviously just one solution. We've obviously got people looking at industrial scale battery storage through chemicals and batteries that you have everywhere. And there's people looking at using electricity to store as potential energy, using old mine shafts, lifting and lowering weights. There's lots of research going on at the moment on how we actually store the energy we produce. Because one of the issues we have, as I say, if there's too much power in the network, then turbines need to be shut down so that we don't overpower the grid and cause other problems by having too much electricity available when people aren't using it. So there's a huge area of research going around in lots of different sectors on what we can do with that. How much do wind turbine technicians get paid? I am very sorry, I don't know the answer to that. We don't have any wind turbine technicians on our staff. Our wind turbine is maintained by an experienced third party who do that professionally, and they maintain and operate it on our behalf, and then support with our research projects, which is our main industry. And it will likely vary between companies as well. So that's a very difficult question to answer. What can you tell me about painting wind turbine blades black or dark grey to make sure that birds do not strike them as much? This is research that's been found to be true according to the RSPB. So will wind turbines be updated to include this? That's a very interesting question. I would really like to see that research. I will need to look it up later. There are some wind turbine manufacturers that paint stripes or darker areas on the blades. I don't know if that's for that purpose, but we're always looking at ways to improve. Obviously, the first wind turbines that were installed, there was not very much consideration given to birds and flight paths and migratory routes, and all of that has to be taken into account during the planning phases these days. You'll have maybe seen a few months ago that the RSPB were putting forward a case for certain aspects of wind farm development off the north-east coast of Scotland, and there's been other discussions down in the south of England as well. So that these discussions are ongoing all the time. The animal welfare, the RSPB obviously, and the environmental agencies are very much involved in all of the planning stages of wind farm development to prevent issues like bird strike happening. What are your thoughts on nuclear energy as a sustainable energy source for the future? I think that nuclear energy is a much better form of energy than coal or gas. It doesn't produce the same greenhouse gases. Obviously, the waste is problematic, but it's on a much smaller scale than more traditional energy. It's a reliable source. It has lots of benefits to it as well, and it's a good way of having a balanced grid as well. So there will be no one source of energy for the future. It's always going to be a blend. So we'll have wind and solar and hopefully wave and tidal and biomass and hydro, and nuclear is going to be around for a long time still to come. And although I know some people are quite concerned about the industry, it's the health and safety we have in this country in particular means that it's much safer than some of the worst stories we've heard from other parts of the world. But our energy grid is always going to be a blend and a combination of lots of technologies. How many jobs could building wind turbines in the UK add in terms of jobs? And are there any factories or suppliers in the UK and east of England? There are so many jobs. So part of the wind sector deal was a plan to triple the number of jobs in the industry over the next 10 years. So we're looking at probably a minimum of 30,000 people working directly within the offshore wind industry in the next 9 years. But there are huge areas for supply chain growth as well. So that's one of the areas that the Offshore Renewable Energy Catapult focuses on, is that local supply chain. And with the planning and government expectations for local content and new developments, there's a huge push for development of local supply chains as well. So in the east of England in particular, you've got the whole Humber region is doing, it's got a huge amount of interest. You've got Siemens, you've got Ørsted, you've got lots of the big companies based there. Up to Blyth, you've got a lot of supply chain like JDR cables and other manufacturing facilities. So there's a huge, huge industry that's developing and advancing for offshore wind. A lot of the traditional oil and gas suppliers are looking to diversify into offshore wind as well, because they can see how much the industry is growing. And actually one of the major concerns for the offshore wind sector deal was that the ambitions to grow the industry to such an extent would be, can we actually get the materials to grow as fast as we want to? So there's a huge, huge area for development in the supply chain. And that's obviously looking at the installation and maintenance of wind farms, but we're now starting to look at the end of life management and decommissioning, and how we have more sustainable sectors, reduce our waste and reuse or remanufacture the components that are decommissioned. So once you take apart a wind turbine, we don't want to just throw it all in the bin. What can we reuse of the materials and the components, and what can be, what can we do to reduce our waste and increase the sustainability of the industry overall as well. So there's a huge area as well that's starting to develop, looking at that kind of circular economy, waste reduction, better, more sustainable end of life management as well. So there's so many areas that jobs and new sectors are developing within. What do you think of vertical axis wind turbines? That's a good question, because you don't see many of them. So there's obviously advantages and disadvantages of every design. We're all used to seeing the three-bladed horizontal axis turbines like the one behind me. And the questions over the 3 blades or 2 blades or 4 blades, or as well, you know, and all of them have their pros and cons. Technically, I think 4 blades, you can capture more energy, but then you're using more materials. So it's a balance between cost and energy production. 2 blades, they can spin faster. You use less materials, but then you get different operational vibrations within the structure, which can you need to take into consideration through the engineering design of the rest of the structure. So 3 blades seems to become the optimum, and within the kind of industry view. Vertical axis, you've obviously got different aspects to think about. So as the turbine spins that way, you've got the air pushing blades back before they go round. So, but then you've also got the blades that are coming round pushing against the wind. So there's been questions of, you know, how much of an effect that resistance has on the energy production. And yeah, I think depends on what the application is for and what you expect to get out of it. It's definitely an option to consider. Do offshore wind engineers get paid more than onshore winds? I don't know for sure, but I would say yes, merely because the very fact that you're working offshore, it's classed as a high risk environment, and any jobs in a high risk environment tend to get paid more for people, you know, taking on that risk. So obviously we do everything we can to make sure that working offshore is as safe as possible, but you are in the middle of the sea in a very windy location, because that's where we install wind turbines. So there's always going to be some risks, and it's how we mitigate those risks that becomes important, and that the safety of the people that are working offshore is absolutely vital. Do wind turbines kill birds and bats? I don't have any figures or reports on those. I believe that in the very early days, back in the 90s, when wind turbines were first installed, there was concerns. As I said, there's a lot of work that goes into preventing any injury to nature in that sense, and there's always going to be discussions on either side for people quite rightly raising concerns, but I have seen photographs of seagulls that use offshore wind turbines as a resting point. There was one project where they installed a bird cam on the top of the turbine, and there was a little congregation of seagulls on the top of the turbine sitting grooming and having a rest. So I think animals are in general smarter than we give them credit for, but there will always be instances likely. I mean, I saw a seagull fly headfirst into a lamppost in Glasgow city centre one time. So there's likely going to be some instance, but I don't think it's as prevalent as we used to be concerned about. What happens to the electricity supply when the wind isn't blowing? Does wind need to be backed up by other sources of power? Yeah, I think I already covered that partly anyway. Until we have a reliable form of energy storage, it's always going to be a mix anyway. So on the days that the wind tends to be blowing the least, that is often when the sun is shining the brightest. So solar power can often take up a lot of the load. Then we've also got hydropower as tidal power develops as well. We've got a reliable energy income twice a day. We know when that's going to be happening with the tides. As wave power develops as well, we hope that that'll contribute towards the grid, but there's always going to be a mix, and wind does a lot of the heavy lifting for the renewable sector at the moment, because the capacity has expanded so much, but as you say, that question of energy storage on the days the windiest days for when it's less windy is going to be vital going forward. Does the steel in wind turbines come from British steel, or is it mainly imported from China? And should we be using more British and European steel? If so, for environmental reasons, if it's imported? That will vary project to project. It's difficult to say. British steel obviously is not as prevalent as it used to be. And we have more, steel finishing manufacturing facilities rather than actual steel, production. And whether we can revive or bring that industry back, or whether we find alternatives. There's a lot of questions over, what alternative materials could be used to steel as well, or can we, as I say, reuse and recycle what we have without having to import as much finished from overseas as well. But the question is a complex one, of course. There's the question of whether we have the actual facilities to do that in the UK, and then there's the question of, can we do that at the necessary scale? Because as we saw at the start there, that wind turbines have grown so much in size that actually some of the facilities that used to be producing wind turbines for onshore, they don't physically have the capacity to do the necessary size for offshore. So again, difficult question to answer. How much energy comes from wind in the UK? I did know this. I don't know if the numbers have been released from last year yet, but from 2019, I believe that it was 17% of the UK's energy came from wind. It was over 25% came from renewables, I think. In Scotland, I know the numbers more readily because I've just been at a Scottish Renewables Conference. Scotland's electricity in 2019, 90% came from wind power, and I think the number was 130% of the electricity we need in Scotland came from renewables in 2019. So we are moving fast, and it is increasing year on year quite dramatically. So it's very encouraging to see that we're going in the right direction. Should wind turbines have little platforms at the bottom for wildlife, kind of like artificial islands so that seals and other animals can jump up to rest? That is a brilliant question. I like that one. Actually, we have been working with a couple of technology developers who are looking at creating artificial reefs around the base of turbines. So sometimes in particularly sandy conditions, if there's deep sea currents, the sand in the base, the ground around the base of the turbine can sometimes move around and get washed away, and we call it a scour. So some turbines have scour protection, where they maybe pile rocks or special blankets around the base of the structure to stop that sand getting washed away. And there's been a couple of developers that are looking at developing all natural material rocks and shapes and things to encourage marine growth and marine life as an artificial reef. So there's research looking into those. I'm not so sure about seals. They tend to have quite specific areas that like to go near rocks and things anyway, and as I say, birds already use them as resting points, and actually bird poo has been quite an issue for some wind farms over the years, and developing devices to try and stop the birds sitting and resting on the turbines, because they leave quite a mess behind them sometimes. How important is CAD in making sure optimum efficiency in aerodynamics? Wow, that's a good question. So obviously 3D modelling and computer-aided design simulations are used a lot in a lot of these areas. The technologies and the softwares available have advanced and developed so much over the last 10 years, you know, using real life feedback to improve the systems, and you know, the aerodynamics analysis has been a major part of that as well. So yeah, it's really important. It's not an area that I'm involved with directly, but I have seen how relevant and necessary it can be to helping improving systems. And there's a lot of research from some of our academic partners looking at how we can use add-ons to the blades called vortex generators, which just break the flow of the wind resistance as the blades rotate to increase the efficiency. So there's a lot of research going on into how to make these systems even more efficient. I read once that a wind turbine lasts about 25 years. What happens after this, and does it just need a new generator, top of the tower, and new electrics to revive it? That's a very good question. And it's one that we're actually looking at right now. The 25 years was more kind of standard equipment life cycle expectancy in the early rounds of seabed leasing, where you actually get the planning permission to build wind farms. They were only initially for 25 years. In the UK, certainly those are now usually more likely to be 50 years. So there's a lot of questions about how we can best do that engineering analysis to see if the structure has been designed appropriately, that it can be either left in place and just upgraded, or whether, so looking at the remaining life of the structure, because it's all looking at at fatigue analysis and the stresses of operation and vibrations, and you've got the wind and the waves and all of those aspects. So how do we do an effective analysis to see what the remaining life of the structure is? And then we need to look at each of the components. Is there any wear on any bearings, or, as you say, electrical connectors? Can anything be refurbished, or does it need to be replaced? There's a lot of questions going on at the moment looking at life extension. So can we take those initial 25 years, and if leases are allow for it, can we extend that out to 50 years? And then there's looking at repowering. So if turbines themselves, their life, remaining life is not expected to be, good enough to extend their lives, can we, remove the structure of the aspect that's not deemed to be suitable, and replace it with something newer and better, but still using all the infrastructure that's there, all the cables and substations and the transformers and all of the electrical equipment, and maybe just replace the parts that are a bit tired, maybe a bit corroded or rusty, because they've been out in the sea for 25 years. All of these areas are still very much under research and review, and hopefully we'll be having some answers soon enough. How can solar energy be incorporated into wind turbines, such as solar tiles that curve around the tower? It's a very interesting question. I don't know if anyone's looked into that, but I have heard rumours of projects looking at having floating solar farms that maybe help feed into existing wind farms as well. So you'd have a floating platform near the wind farm that would be covered in solar panels. So yeah, it's an option. But as you know, people have a lot of solar panels on their own roofs and things as well. So it's a question of, where's the best location if you're then having to transport that energy back to shore as well. Is it necessary? Oh, thank you very much. getting to all these nice comments here. Do you offer apprenticeships or work experience to help get a job in this field? We have 2 modern apprenticeships in our Glasgow office in our procurement department at the moment. I believe we have had apprentices at our test facilities in Blyth in the north of England. We do try and offer, summer internships and industrial placements when possible. Obviously, the last year has made that a lot more difficult because we've not been in the office, but I hope that coming out of this chaos over the last year, we can get back to that. We do what we can to try and support schools and education, and give an insight into what incredible projects that are going on in the industry as well. So there's a huge amount of things that we'd like to do and we'd like to get back to as well. So how much energy does a wind turbine supply? So the current largest turbine in the world, I believe, is at 10 megawatts. And I don't know how to put that into something that makes more sense for you. I think, right, so they're talking about the wind turbines that were just installed at the, there you go, thank you, 60,000 to 8. Is that 6,000 to 8,000 homes or 60,000 to 80,000 homes? Anyway, 6,000 to 8,000 homes. Somebody's quick on Google or already knows that one. The Aberdeen Bay wind farm, the European wind offshore demonstrator, currently installed just off Aberdeen by Vattenfall. They were saying that a single rotation of one of those turbines blades is enough to power an average household for over 32 hours. So hopefully that gives you a bit more of a context. How much do wind turbines cost? Again, I'm sorry, I don't know the answer to that question. We don't work in the manufacturing side of things, and I imagine it probably varies between different manufacturers, and it will depend on how many you want to buy for your wind farm as well. There's probably some kind of cumulative cost reduction there. Are wind turbines noisy? They're it's a difficult question because I think a lot of it's subjective as well. I mean, I don't know if you've ever been up to an onshore wind farm. It's it's just the sound of the wind passing. I don't find them particularly noisy, but I do know of people who don't like wind turbines who find them incredibly annoying. We obviously have noise restrictions when you're near residences, so that people who live nearby aren't disturbed or upset by them. So our wind turbine on the coast, it's right next to the village of Methil, and we do on occasion know that there are certain wind conditions where the turbine needs to be shut down because it can cause vibrations that upsets the local people. So.
Thank you, Lorna. I think that's absolutely excellent. Has anyone got any just wrapping up questions for Lorna? Because we need to just... Anyone? Thank you so much, Lorna. That was excellent. Really, really interesting as well. And I'm quite impressed with your broad amount of knowledge, considering like you don't do all renewable sectors. There was a lot of broad questions there, definitely. So yeah, thank you guys. And if you want to watch this back on playback as well, we have been recording. We'll put that live. If anyone would like to watch anything else. That's everything from us. Lorna, have you got anything else to add?
No, just thank you very much for your wonderful questions. I hope I've managed to answer them all suitably.
Definitely. Some of them were hilarious. It was very, very entertaining. Well, thank you so much, guys, for attending our second STEM-tastic event, and we hope you enjoyed Lorna's talk. But we hope to see you guys on a few more sessions. Thank you so much, Lorna. See you soon.
Bye.
Bye.